Today we're going to be talking about complex numbers. So you should have 5-4 complex numbers. So let's start looking at our lesson. So it says, suppose the number I is defined such that I squared equals -1, and we're going to complete each equation. So let's look at our first few examples. My first one says, I got 2I squared. So remember, I squared is the same thing as a -1. Okay, so when I have 2 times a -1, I get -2. My next one says 2I, and then in parentheses, it's squared. So remember, I got to multiply that out. So 2 squared is 4, and I have I to the second power, which is I squared. So 4 times a -1, I get -4. And then look at my last one. It's I to the fourth. Well, I to the fourth is the same thing as saying I squared squared, or I squared times I squared. So I have a -1 times a -1, which in turn is going to make it a +1. So let's look at some definitions. My first definition, remember the form A plus BI. That's called the standard form of complex numbers. So that's typically how you're going to see them written. Okay, so let's look at an example. In a complex numbers, for instance, 4 plus 5i, the real part is going to be the number 4, and the imaginary part is 5i. Remember, if there's an I with it, it's going to be imaginary. So this example of a complex number is also an imaginary number. Okay, let's look at another example. In the complex number 3, the real part is 3, and the imaginary part is actually 0i. If I don't have an imaginary part, then this example is going to be called a real number. Okay, let's look at the last example. My last example is in the complex number 7i, the real part is 0, and the imaginary part is 7i. So if I only have an imaginary part, it's called a pure imaginary number. Okay, those definitions we've talked about a little bit. So let's look at a few more examples. It says we're going to give the complex conjugate of each number. Now, what is the conjugate? We defined it a little bit ago. Y'all should have said it's where I changed the sign of the imaginary number. So let's look at some examples. Okay, so if I have 3 plus 7i, the conjugate would be 3 minus 7i. Again, we're changing the sign of the imaginary part. So in B, I have 2 minus I. So my conjugate is going to be 2 plus I. Okay, now let's look at some of these questions. Number 3 says, why are complex conjugates used in dividing complex numbers? So here, the product of complex conjugates is always a real number. That is why we actually use it in division. Okay, so let's look at question number 4. Now, I want you to pay close attention to this. You guys actually saw this on your final. Okay, it says, explain how you would use the complex conjugate to find 3 plus 7i divided by 2 minus I. So our first step is always to rewrite the equation as a fraction. So step number 1 is rewrite as a fraction. So if you look, I rewrote it as 3 plus 7i with my division sign and 2 minus I. The second part says I'm going to multiply by the conjugate of the denominator. So the denominator is 2 minus I. We'll back up in number 2. We said the conjugate was 2 plus I. So we're going to multiply both numerator and denominator by 2 plus I. So what's going to happen is my denominators, the i's will actually cancel out. Okay, now we'll work a few problems here in a minute. So the last thing I want you to do, look at number 5. It says, how can you use what you know about simplifying an expression to help you to remember how to simplify fractions with imaginary numbers in the denominator? So based on what I just talked about, I want you guys to answer question 5 for homework. Okay, so flip the page over and let's look at a few examples. Okay, so let's look at our first example. Let's look at problem number 1. It says I got the square root of 99. Now we talked about this on how we were going to do factorization trees. So let me give you a quick example. So if I have the square root of 99, we're going to come up with factors that I can actually reduce. So what two numbers can I use to multiply to get to 99? I could have said 9 and 11. If I break 9 down, it's 3 and 3. Now remember, for every pair of numbers that you have, one of them is going to come outside of the radical or the square root. And whatever's left, which is my 11, is going to go underneath the radical. So again, that's how you reduce square roots. Okay, so let's look at another example. Okay, looking at the second section, it says we're going to solve each equation. So let's look at 17. It says I have 3x squared plus 3 is equal to 0. Okay, so when I work that problem out, my goal is to get x by itself. So I'm going to subtract 3 from both sides. I have 3x squared is equal to a negative 3. Divide both sides by 3. So I end up with an x squared is equal to a negative 1. Now when I square root it, when I square root a negative, what do I have to take out? That's right, an I. Now remember, your definition is that I is actually equal to the square root of a negative 1. Now remember, when we square root, we must put that we have a plus and a minus for our answer. So my answer for number 17 would be that x is equal to plus or minus the letter I. Okay, so you're going to use that example to answer the second section. Now let's look at the third section and look at question 23. Okay, on question 23, I have 20 minus 12i is equal to 5m plus 4ni. And it says find the values of m and n to make the equation true. So what we're essentially doing is looking at my first value, which is 20, and seeing what number can I multiply 5 by in order to make it 20. So here, I know that 5 times 4 is going to give me a positive 20, which will match this value right here. So I know that m has got to be equal to 4. Okay, so let's look at the next one. My next one for n, I have a positive 4. I'm looking to get a negative 12. So 4 times what will give me a negative 12? That's right, a negative 3. So n is equal to a negative 3. All your goal is to try and put numbers and replace the m and the n in order to equal the original equation. So you're going to use this example on the last section. So we're going to work the rest in class. Make sure you have this copied down, and I will see you guys tomorrow.